Hello friends, so this is the fifth question related to application of Norton's theorem. So here we have is this circuit and we have to find the Norton equivalent circuit. So first we'll find the Norton current. So for that we'll redraw the circuit, short circuiting these two terminals. Okay. So this is 40 volt, this is 10 ohm, this is 40 ohm, this is 20 ohm, and we short circuit these two terminals. This is 3 ampere. Okay, so we have to find this current here. Okay, so we can use mesh analysis or we can use nodal analysis. Mesh analysis will give us a lot of equations, so we will go for nodal analysis. Okay, so let us try to solve it using nodal analysis. So let us say this voltage here is V. Let us assign the current directions. Let's say one current flows like this. This current is flowing 3 ampere like this. Let us say this current is flowing downwards, and this current here flowing like this. So let us write the nodal equation here. All the currents are flowing away from node V except this current. Remaining currents are flowing away. So this will be on one side, 40 minus V by 10 is equal to 3 ampere plus V by 40, that is V minus ground potential by 40, that is V by 40, ground potential is 0, plus V by 20, V minus ground by 20. Okay, that implies 40 by 10 minus V by 10 is equal to 3 plus V by 40 plus V by 20. This is simply 4. So that implies if we take 3 to this side and V by 10 to that side, it will become 4 minus 3 is equal to V by 10 plus V by 20 plus V by 40. That implies 1 is equal to LCM is 40, so it is V plus 2V, sorry, it is 4V plus 2V plus V. So it is plus 40 is equal to 7V. That implies V is equal to 40 by 7 volt. Okay, V is this much. Now current flowing through this 20 ohm resistor, let us call it I 20 ohm, that is V by 20, which is 40 by 7 divided by 20, which is 40 by, let's say this. Let us say this is 22, this is 2 by 7 ampere. IN is equal to this I 20 ohm plus 3 ampere, that is 2 by 7 plus 3. So it is 23 by 7 ampere. So when we to this, write in decimal form, it becomes something around 3.286 ampere. So that is the Norton current. Okay. So first we determined the current flowing through this 20 ohm resistor, then we added this 3 ohm and this I20 ohm current flowing through the 20 ohm resistor to get IN, okay, which we got as 3.286 ampere. So we have got the Norton current. Now we have to determine the Norton equivalent resistance. Okay. So for that, what we have to do is we have to find out the equivalent resistance deactivating the independent sources. So this voltage source will be short circuited first, 10 ohm, 40 ohm, 20 ohm. The current source will be open circuited. B. This is 10 ohm, this is 40 ohm, this is 20 ohm. Now here 10 and 40 are in parallel connection with respect to each other, and the resultant is in series with 20 ohm considering these 2 points. So Rn will be 10 parallel 40 plus 20, which is equal to 10 into 40 by 50 plus 20, which is equal to 400 by 50 plus 20. 400 by 50 is simply 8. So it is Rn is equal to 28 ohm. Rn is 28 ohm. In is 3.286 ampere. So this is the Norton equivalent circuit. .286 ampere. This is 28 ohm. This is the Norton equivalent circuit for this circuit here. Okay. So this is the 5th question related to application of Norton's theorem to electrical circuits. Okay.